Let us now look at a brief description of an experiment that can be used to determine the center of gravity. From the definition above, the center of gravity of a body lies at the geometrical center. COG lies at the geometrical center. For that matter, therefore, center of gravity of regular shapes such as rectangles, triangles, and the rest can be determined through geometrical construction. However, for an irregularly shaped lamina, we have a different way of determining the center of gravity. First, it is important to understand the definition of a lamina. A lamina is a thin plate or scale which is irregularly shaped. To determine its center of gravity, we need a plumb line, we need a retort stand, and we need the lamina itself. The lamina is suspended as shown here, and a number of holes A, B, C, D, E, F are made on the edges of the lamina. When the apparatus are arranged as shown below, we note that the suspended lamina will always rest with its center of gravity vertically below the point of support. So, if we support the lamina through hole C, for example, then the lamina will always rest with its COG vertically below the point of support. The lamina in this case balances on the tip of the hole placed at its center of gravity. So, in order to determine the center of gravity, we will allow the plumb line to pass through all the holes. Then we make straight lines along the plumb line. The point of intersection of the lines drawn, like in this case we have line AD, we have line BE, we also have line C, where the plumb line moves. When lines are drawn through such points, they intersect at a point G. Lines intersects. The point G where the lines intersect is the center of gravity of the lamina. And that is basically how the center of gravity of a lamina is determined. Let us now look at an example on the center of gravity. A uniform meter rule is balanced at 20 centimeter mark when a mass of 2.5 kilogram is attached at the 0 centimeter mark. Calculate the weight of the meter rule. First, we have to understand that the weight will always act at the center of any object. So if this meter rule is able to balance when a mass of 2.5 kilogram is hung on one end, then it means that the two forces that causes this state of equilibrium are the mass of 2.5 kilogram and the weight, which will act at the center. So the center is 50 centimeter mark. Is at 50 centimeters mark. To calculate the weight, we apply the principle of moment. That is the sum of clockwise moments equals the sum of anti-clockwise moment. The clockwise moment is created by the weight, while the anti-clockwise moment is created by the mass of 2.5 kilograms. We deal with forces, and therefore it is important that we convert 2.5 kilograms into newtons by multiplying it by 10. We multiply by 10 because force, which in this case is the weight, is given by mg. If we take g to be 10, then we have 2.5 times 10, which is 25 newtons. So applying this and substituting, we have the weight, which creates the clockwise moment, multiplied by the distance, which is 50 minus 20 is 30. Centimeters. This should be equal to the force 25 newtons multiplied by 20 minus 0, which is 20 centimeters. All the distances are measured from the point of balance, which we also call the pivot. So weight is equals to 25 times 20 over 30. When this is calculated, we get a value (16.667 which is approximately equal to 16.67 newtons to 4 significant figures. Now in this case, it is important to note that we have not converted the distances into their SI units. This is because these distances will cancel out, so that if we have 30 centimeters, we also have 20 centimeters. When we divide, then the SI units of length cancels out.